forecast that we'd get to this point somewhere around 2040, 2050, that maybe by the end of the century we would see an open Arctic Ocean. Now nobody is willing to predict that that will happen, that all of that ice will be gone in late summer any later than 2030. Things are changing really fast, and the feedbacks are happening faster than we thought. And here, you can see a longer record going back all the way to 1900. We have pretty good records from ships and stuff that sailed through the Arctic Ocean, just whether or not we've ever seen anything like this, at least within the last century. And you can see how, even though there were a few minor ups and downs through the years over the last century, we've never seen anything as dramatic as this in the past. Let's see if we get lucky with this. I want to show you why it's going so much faster. What you're seeing here is a record of sea ice. The red is very old sea. It's a record of sea ice for the last 30 years. And that blue flashing out and it's contracting, that's the winter growth and the summer melt every year. Now, some scientists here in Boulder, Chuck Fowler and Jim Mislanik, they take images every day. They track the ice. And they keep track of it year by year, so they can tell when you've got really old ice that stayed there in the Arctic for a long, long time, and much younger ice that just showed up. By tracking it, they can show you how it circulates. Now what we found, and this also was a stunner, what we found, I think I'm going to have to go like this, and then start it up again, is that the Arctic has a lot less old ice in it anymore, and there's two reasons for that. One is that you may have heard that wind patterns in the 1990s favored pushing this ice out this way, out through Greenland, which is sort of normal. But what's not normal, watch this area up here. In the beginning, this ice would make it and circle around the Arctic and just stay there for year after year. But in the later years here, now we're into 2005, 2006, that ice doesn't make it past Alaska and Siberia. The summer that happens in the years that it's traveling through this area right here means that it gets melted out before it can get there. We can't put this ice back in the hopper and keep it circulating in the Arctic and keep it covered with thick ice. What we see last year and what we're seeing this year is that all of the old ice, all of the ice that's likely to survive, is tucked up here against Canada and much, much smaller than it was even a decade ago. Now, it's likely that this summer, the way it's looking, setting up for this summer, that we'll see, for the first time ever, an open water North Pole. Now, you can listen for that this summer. Maybe it'll be this year, maybe it'll be a few years from now. Right now, as near as we can tell, there's a very strong chance that at the North Pole, it'll be open water. You could take a sailboat there, no icebreaker needed. Has that ever happened before? I mean, is it possible that the Vikings would have missed something like that? I don't think so. All right, Greenland, another big problem for us, and another place where changes are happening really rapidly. Here's some more work from the University of Colorado, and I do want to say that you guys, I hope you appreciate it, I think you do. Boulder happens to be probably the world's greatest place for studying climate change. We have a number of groups with just some fantastic scientists. And the thing that everybody else envies about us is that we really work together all across those groups. NCAR, University of Colorado, the group that I work with, INSTAR, Institute for Arctic and Alpine Research, they all work very close together. And that's what all these other places on the East Coast and around the world try to emulate. And I just wanted to say in passing that, because I'm going to show a lot of University of Colorado stuff, I'm showing you pretty much the stuff that the world recognizes is the cutting edge science. Here's some from this fellow, Connie Steffen, who's actually the boss of the Ceres Institute, on how much of Greenland has melted in 2005. That was the record. You can see it's a huge area down here in the southern tip of Greenland, and those dark red squares there are showing places that had never melted before in our satellite record. Never in 30 years have we seen those areas melt. And every year there's a few more of these little squares that are melting for the first time ever. Well, what happens to all that melt? It starts running off of the continent and into the ocean. But it doesn't just run off on the surface. What happens, what we found, is that when you get a lot of melt on the surface, it'll dive down into the ice and get underneath the ice. This is a big problem because having that water layer between the ice and the rock means that the ice slides out a lot faster. That's going to accelerate glaciers even more. Back in the 1980s, back in the early 1990s when I got started in all of this, the thought was, yes, there's going to be climate change in the poles, but we're going to need to wait to have the ice actually melt in the sun and run off to get it into the ocean. And so it's going to take centuries for a place like Greenland to really change. And then we learned that that's not the case, that there is this effect where the water gets into the underside of the ice, lifts the ice off of the continent, and causes the glaciers to ride out that much faster. And so we saw things that we didn't think we'd ever see. What we saw was that glaciers started breaking up. This is the largest glacier in Greenland, and it's also the fastest glacier on Earth. It's the once and now again fastest glacier on Earth. You can see how it retreated as we came out of the little ice age in 1850 and really started warming up in the last part of the last century and this century. It retreated, and at the same time, it doubled in speed. It doubled in speed within just a decade. So this thing, I said, it's the fastest glacier on Earth. It moves about 15 meters per year in the 1990s. Now it's moving close to 40 meters, 40 yards per year. 40 yards per day, 40 yards per day. And it doubled from the 1980s up there to a few years ago. And that means that twice as much ice is coming out and going into the ocean and raising sea level. And that's a big deal. There's several other glaciers in Greenland that are doing the same thing. This is just the largest one.